Today we talk about systems of inequalities, and the difference between systems of inequalities and systems of equalities is when we're talking about a system of inequality is that we get a solution at a point. When we talk about a system of inequalities, our solution is actually a region of points that satisfy the conditions given in the initial problem. So here we have our first example. And in order to actually do these problems, we need to take a look at a coordinate graph. So let's do that. Let's draw one, just sketch it, nothing professional. All right. And we want to graph first the equation x is greater than or equal to 2. So if I mark 2 and draw an x equals 2 graph, it's a vertical line. Guys like this. And what we want to do is we want to shade the area in which all x values are greater than 2. Well, in this area to the left of this vertical line, those x values are less than 2. So the areas greater than 2 are over here. I'll just hash that area in. All right, let's change to a different color. And we will graph x is less than or equal to 5. So here's 5. And I'm going to draw another vertical line. And I'm going to shade where all the values of x are less than 5. So that's everything to the left of that blue line. Finally, we're going to take and graph this linear equation that actually has a slope now. So we're going to go to a y-intercept of 1. And then we're going to rise 1 and run 1 to get our slope. And this creates a diagonal line. Now in this case, if we want to shade it, what I do is I find what's called a sample point. And a sample point is any point in the xy coordinate grid that you want to choose to test. All right, and I usually choose the point 0, 0. And when I plug 0, 0 into this equation, I get the following. 0 is greater than or equal to 0 plus 1. Now, that yields 0 is greater than or equal to 1. This is a false statement. So I know that this point 0, 0 does not satisfy my inequality. Thus, I need to shade away or in the other region of the graph that would satisfy that inequality. And now I look at what I have left. And what I have left is I have 3 lines. I have 3 shaded regions, and my region in which all inequalities are satisfied is the triple shaded region. So that's the region up here. And at any point in this region is a solution for this system. Let's move on. So now, again, we have 2 linear equations, and we're going to graph both. The first one's already in a nice form. I'm going to take and put the second one in the slope-intercept form. So that's y is greater than or equal to negative 5x plus 12. Graphing the first equation, I go up 1 for my y-intercept, put a little dot there, and then I rise 1, run 1, dot, connect the points, and I'm looking at something like this. For this, I pick a sample point, 0, 0 once again. Sample point yield 0 is less than or equal to 1. That's a true statement. So I'm going to shade toward the point 0, 0. Now, our next inequality has a y-intercept of 12. We're going to guesstimate that's somewhere up here. And then I go down 5, which is pretty steep, and over 1. This is a little bit of an approximation, but you get the idea. Connect the dots. Get a line that looks something like this. Again, I'm going to pick a sample point of 0, 0. 0, 0 will yield 0 plus 0 is greater than or equal to 12. We know that's a false statement. So if I picked 0, 0 as my sample point, and this region is false, it means I must shade away from that region or to the right of that line. So now my double shaded region is this area over here, and every point in that region is going to satisfy the two inequalities. Let's do another one. This time we'll graph that third equation a little bit differently. So here is x is less than 5. Let's call 5 right around over here. We've graphed a vertical line like this before. And we shade wherever x is less than 5, so that's over in this region here. Next, we'll take and graph y is greater than 1. Well, here's y is equal to 1. And we know y equals graphs are horizontal. And where are all the y values greater than 1? Above that line. So I've shaded that area. Now for this last equation, previously we took and put this in slope-intercept form, or y equals mx plus b. But what I'm going to use now is I'm going to use some intercepts. And if we talk about intercepts, we're talking about the x-intercept and the y-intercept. For all x-intercepts, we know that anywhere on this line, the y value equals 0. And for any y-intercept, the x value equals 0. So what I'm going to do in each case is plug in that value for x or y. So first let's find the x-intercept, and for that we will say 4x plus 5 times 0 equals 40. So x in this case is equal to 10. So somewhere over here, call this 10, I get a point. Now for the y-intercept, I'm going to do something very similar. I'm going to take and set x equal to 0. So I have 4 times 0 plus 5y equals 40. And y is going to equal 8. So if this was 1/8, let's call it somewhere up here. Put a dot there. I'm going to connect the two dots because I know those are 2 points on a line. All right. And then now what we'll do is we'll take and pick a sample point once again of 0, 0. So sampling this again, we get 0 plus 0 is less than or equal to 40. We know is a true statement. So since 0, 0 is in the solution space, we shade towards that. And let's use a different color just so we don't get too confused. 0, 0 shades, if you will, to the left. And then I have a triple shaded region now of this, actually it's kind of like a trapezoidal region here. And any point in that region will satisfy that system of inequalities. So we'll go ahead and do another one. Now, the first equation is interesting in that if we were to take and use intercepts, we notice that if I set x equal to 0, then y is equal to 0. If I set y equal to 0, then x would equal to 0. So our intercepts are actually both 0. So it's really not going to help us when we choose a sample point, or it's not going to help us find the slope either. So for that first equation, I'm going to take and put that in slope-intercept form. So I have 2y less than or equal to negative x. And y is less than or equal to negative 1/2 x, which means my y-intercept is 0. I go down 1 over 2, draw a graph. And like I said earlier, in this case, our sample point of 0, 0 is not really going to help us because 0, 0 is actually on the line. So I'm going to sample another point that's not on that. In this case, I think I'll just pick the point 1, 0. So if I plug 1 and 0 into the x and y for this inequality, I get 1 plus 0 is less than or equal to 0. We know that's false. So here's my point 1, 0. I knew that that's not in the solution region, so I shade away from that point. Next, I'm going to take and graph the second equation, and that has a y-intercept of 7. And a slope of negative 1. So I'm going to go down, I'm going to take and go down 1 and over 1. And I get something of this nature. And these will eventually cross. Now again, I pick a sample point for the second equation, 0, 0. And I get 7 minus 0 is less than or equal to 0. We know that is false. So in this case, I shade away from 0, 0, which means I shade up. So what's going to happen, if you can imagine, when these intersect, they'll do so way the heck out here. Where these guys cross. And so far, my intersection is going to be in this region over here. Finally, I'm going to take x is greater than or equal to 6 and graph that. So let's call this 6 out here. 1, 2, 3, 4, 5, and 6 probably. And I'll go ahead and graph that. So now I have to shade everywhere where x is greater than that. And I notice now that I'll have a triple shaded region, but that region's not going to happen until way the heck out here. And those points in that region will satisfy the solution. We're going to do a quick review now. Let's take and graph the absolute value function, which we did yesterday, I believe, maybe the day before. We know that the 1 represents our h value, and our k represents the k, our 5 represents the k value. H refers to a horizontal translation. So we know that these are all of the form x minus h. So we have basically x minus a negative 1 in order to get a plus 1. Therefore, the h value is negative 1 and the k value is 5. We also found that the 3 represented our slope. So what I'm going to do is I'm going to translate 1 to the left, 5 up, and put our translated origin point, if you will. Now, from that point, we have a slope of 3. So if I rise up 3 and run 3, I get 1 part of my absolute value graph. Now we know that all these look very similar to a V shape, and they're symmetric both to the left and the right of the vertex. So if I go up 3 and back 1, I get the other half of my absolute value graph. And now, since this is an inequality, I have to go ahead and shade everywhere where y is greater than this function. And again, I'm just going to go to that sample point. I'm going to pick my sample of 0, 0. So I have 0 greater than or equal to 3 times the absolute value of 1 plus 5. So this says 0 is greater than or equal to 8. And we know that is false. So 0, 0 were my sample point. Then I have to shade everywhere that's not in that region that 0, 0 lies. So that's everything inside the V. And that will satisfy my inequality there. Let's do one last. Again, it's an absolute value. So I look and I identify my H value of 2, my K value of -3, my slope of -1/2. So I translate 2 to the right, down 3. There's my translated origin, and from there I go down 1 and over 2, which puts me roughly here. And I do that both to the left and right of that translated point. So here's my absolute value graph. And then I just have to use a sample point. Once again, I'm going to use 0 and 0. And that gives me 0 is less than or equal to -1/2 times the absolute value of -2 minus 3, which gives me 0 is less than or equal to. This isn't 2 times -1/2 is -1 minus 3, and we know 0 from that is less than or equal to -4, which is again a false statement. So if this is the false statement, nothing in this region satisfies the inequality, so I must shade once again inside that absolute value region. So again, I've got some questions for you to answer. Here are the first 2. Do we have 3? No, there's just 2. So you're going to answer these 2 questions on the form, and they're multiple choice, so just put in the letter, and we'll get back to you tomorrow. Thanks.